Hello and welcome back. In the last video, we talked about how to solve systems of linear equations by elimination. In this video, we're going to be doing two more examples with elimination, and both of these examples are going to involve cases in which we can't cancel out the variables right away. And I'll show you what I mean by that. So let us consider the two equations 2x plus 3y is equal to 6 and 3x minus 6y is equal to 9. So I will rewrite the equations again over here. And again, our goal here is to cancel out either the x variable or the y variable so we can solve for the other. Now you'll notice that we can't cancel out these variables right away. So what we'll have to do is multiply one of the equations by a number. And so what I'm going to do is multiply the first equation by 2. Like so. So if I multiply the first equation by 2, that means that all the terms will get multiplied by 2. So 2 times 2x is 4x, 2 times 3y is 6y, and 2 times 6 is 12. So multiplying that equation by 2 gives us 4x plus 6y is equal to 12. And of course we have the other equation. And so the whole reason we multiplied the first equation by 2 is because we can now see that we can add the two equations together to cancel the 6y and negative 6y terms. So if we add these two equations together, we have that 4x plus 3x is 7x, 6y plus negative 6y is 0, and 12 plus 9 is 21. So we have 7x plus 0 is 21. That is 7x is equal to 21. Okay, so once again notice that by using elimination, by adding the two equations together, we were able to eliminate the y variable, and that will now allow us to solve for x. To solve for x, we'll just divide the left-hand side of the equation by 7. That means we must divide the right-hand side of the equation by 7. The 7 terms will cancel out, and we'll have x is equal to 21 over 7, or 3. So there you have it, x is equal to 3. Once we have that, we know we can substitute x is equal to 3 into either one of the original equations to solve for y. I'll plug it into the first equation. You'll have 2 times 3 plus 3y is equal to 6. 2 times 3 is 6, so we have 6 plus 3y is 6. I can subtract 6 from the left-hand side of the equation. That means I have to subtract 6 from the right-hand side of the equation. 6 and negative 6 cancel out, and I'll be left with 3y is equal to 6 minus 6, or 3y is equal to 0. And from there I can divide both sides of the equation by 3 to get y is equal to 0 divided by 3 for 0. So we have x is equal to 3 and y is equal to 0. That tells us that the point of intersection or solution of this system of linear equations is 3, 0. And that would be our final answer. So notice that once we multiplied the first equation by 2, all the other steps that we took were the exact same steps that we would take compared to the two examples that we did from last time. Add or subtract the two equations to get rid of a variable, solve for that variable, plug that value into one of the equations and find the other variable. And that gave us the point of intersection or solution. So I'll do one more example. In this next example we have 8x plus 4y is 8 and 2x minus 7y is 18. So once again, we cannot just add or subtract these equations right away because nothing will cancel out. But we notice that 2 goes into 8 4 times. So what I can do is multiply the second equation by 4. That'll give me 8x minus 28y is 72. Right, because 2x times 4 is 8x, negative 7y times 4 is negative 28, and 18 times 4 is 72. Okay, so I can rewrite the other equation again. And from here, we see that all we have to do is subtract the two equations because 8x minus 8x is 0. So that's the other thing. We don't always have to eliminate the y variable. If we want to eliminate the x variable instead, we can, as long as we eliminate a variable. So here that will give us 8x minus 8x is 0, 4y minus 28y is 4y plus 28y, which is 32y, and then 8 minus 72 is negative 64. So we have 0 plus 32y is negative 64, or 32y is negative 64. And from there, all I have to do is divide the left-hand side of the equation by 32. That means I'm going to divide the right-hand side of the equation by 32. The 32's cancel out, and we're left with y is equal to negative 64 over 32, or negative 2. So we have y is equal to negative 2. Once again, I can plug that into either one of the original equations. I'll plug it into the first equation. I'll have 8x plus 4 times negative 2 is 8. That is 8x minus 8 is 8. And then from there, I have to solve for x. We will begin by adding 8 to the left-hand side to get rid of the negative 8. That means we must add 8 to the right-hand side as well. Negative 8 plus 8 cancel out, and we're left with 8x is equal to 8 plus 8, or 8x is equal to 16. From there, I divide both sides of the equation by 8 to get x is equal to 16 divided by 8, or 2. So there you have it, x is equal to 2. This tells us that we have x is equal to 2 and y is equal to negative 2, so the point of intersection or solution of the system of linear equations is 2, negative 2. Now I want to note that this was not the only way we could have went about doing it. So going back to this, keep in mind that we multiplied the first equation by 4. Technically, we can also divide equations by numbers. So another way of going about this would have been to divide the first equation by 4, because that would give us 2x plus y is equal to 2. Right, so 8x divided by 4 is 2x, 4y divided by 4 is y, and 8 divided by 4 is 2. The other equation would stay as is, and now we can subtract the two equations, keeping in mind that 2x minus 2x is 0. We'll also have y minus 7y is y plus 7y, or 8y, and 2 minus 18 is negative 16. So we have 8y is equal to negative 16. Then from there we can divide both sides of the equation by 8 to get y is equal to negative 16 divided by 8, or negative 2. So again, we have y is equal to negative 2. That's the same thing we got from last time. And from here we can plug it into the first equation again. And again, just like last time, we'll have 8x minus 8 is equal to 8. We can add 8 to both sides of the equation. Negative 8 and plus 8 cancel, and we'll have 8x is equal to 8 plus 8, or 8x is equal to 16. I can divide both sides of the equation by 8 to get x is equal to 2, and I'll have x is equal to 2. This is the exact same answer we got from last time, which is expected. No matter what we do, we should get the same answer, which is that the point of intersection or solution is 2, negative 2. Both of those methods of going with the equation are perfectly valid. They both give the exact same answer. It's really up to you whether you would have preferred to multiply the second equation by 4 or divide the first equation by 4. Personally, in this equation, I think that dividing the first equation by 4 gave us smaller numbers to deal with, so it was a bit easier. But in reality, you always have the option of dividing or multiplying an equation by any number that you choose. As long as you can cancel out one of the variables when adding or subtracting the equations, everything else should work out. So that's all I wanted to go over for this video. Thanks for watching.